Hello everyone. I think at least couple of you are waiting, I can see. So I hope some more will join. Whatever we are recording now is last lecture's dynamic fracture, and probably within 2 days we will finish the lectures for dynamic fracture. And but I think I will write a detailed reply in your in the discussion back course feedback. I'm not so sure actually. I need to talk to our this MOOC's office here, and I'll let you know. I'm not sure exactly which link will provide you the feedback, and however, so I will take probably some feedback directly from your side as well. So that I will take later. But the official feedback I need to check, and I'll let you know about that. And so I think our course is it will be just over 30 hours. So I'm actually trying to finish as early as possible without taking too many hours, because anyways I'm a little pressurized to from the MOOC's management as well, that we need to finish very soon. So already I'm late, and so that's why I want I recommend you to study more details on dynamic fracture and dynamic shear bend. So from the Mark Mears book, because we are not going to cover all of them. So because our especially the hours are limited and we don't have much time to record our videos. So I think for shear bend chapter I already completed, and I think that's not all the part, but it should be enough for your the first basic knowledge on shear bends. For dynamic fracture, it's a very vast topic, and if you are more interested, you can refer to L.B. Freund's the book on dynamic fracture. That's a very classic book, but it is a very rigorous treatment of the dynamic fracture. So what we will discuss in this course about dynamic fracture is very basic, just to let you know that there are some differences of dynamic fracture than with our conventional quasi-static failure. So I can see that a couple of you are watching, and if you have some doubts you can post it, and then some of these doubts I can see that okay, so there are lot of issues related to assignment questions. So I can see only one query that I need to check, but I did not get more queries. Please write to me in the discussion forum. So Dharmendra Kumar, Mr. Dharmendra Kumar. So I think I can understand that one question I think I got in the discussion forum, that there are some issues. There may be some issues. I admit that there may be some issues, maybe due to some reason. But I think please be specific and write to me in the discussion forum. Very soon I will give some response on that, and if it is wrong from my side or our side, then I think you don't need to be worry about that. So yeah, I admit that there can be something I didn't check it properly after but after you sent me a query. I don't know who sent me about one doubt regarding one assignment question very recently, but earlier for assignment 1, 2, 3 some doubts already I clarified, and some mistakes were there from our side. So I will take care of that. So can you be please specific on which question on in which assignment? I can at least note it down now. So please tell the number, and it is better you write it in the discussion forum. Be specific, like suppose question number 5 in the assignment number 7, and what is the problem, so that then it will be easier for us to handle it. And I think also Yeah, I actually, encourage you to ask as many as doubts, because we have time till the exam, although we'll be finishing the course soon. And though I am not replying, very frequently because of my hectic schedule here, but still, I will write to you, I will reply each and every response, and if you are not satisfied with my response, you can again, write me back on that, so in the same discussion forum. And I hope I have not missed any earlier doubts, but these doubts I have checked very recently, and then I will upload these doubts very soon. So some of the doubts I can see that, I understand, sorry about that, probably these shockwave chapters are very confusing for you, and this is the first time I am also teaching, and probably I admit that some of the confusion probably I made it. So first, I think the doubt is, someone is asking about release wave and reflected wave are the same. Actually, release wave is the rarefaction part of the wave. So that means the pressure will be very low, or sometimes we can say actually pressure will be negative in that portion. So pressure, that release means the pressure will be released. So because shock wave involves high pressure, and then after that release wave means that release of pressure to a low value. Exactly, if you in exact sense, it should be negative pressure, not exactly zero pressure. That another question says, I think one of your queries was a very important. I found it that should be yes, that somebody asked me, probably Mr. Vinayak, and asked about that release wave. Release wave is should be tensile, like kind of negative pressure. Yeah, that is true actually, but I think Mark Meier's book that ignored that part. So I will probably send you a detailed response on that, because why it is ignored, because that negative pressure is very low, the value is very low as compared to the high pressure involved in the shock part of the wave. So that's why it is the release part is it's not shown as a negative pressure. So it's just shown that the pressure will be relieved to zero level. It's shown like that. And there are other queries. I think this I made you confused about these things. So that I can tell you now that if you see the, if I'm sure that you have, all of you have this Mark Meier's book. So if you see this, this is, I think you can see that the table 4.1 from, I think, whatever version I have, that is page number 108. So that page has, in the table says that it's, you can see here, shock wave, sorry, this is, I think, it can be visible. So you can see here that C, the sonic wave velocity and particle velocity UP and shock wave velocity US. So if you see that at very low pressure, it is written as 0 gigapascal. So at very low pressure, it is assuming that the shock wave velocity is approximated as a sonic wave velocity. I can see that at least 3-4 of your doubts are related to this table, I think, although you did not mention, but you can check the table. And what you can do is, see, at very low pressure, suppose if we talk about copper, so it has 3.94 kilometer per second shock wave velocity, and the sonic wave velocity at very low pressure is 3.94 kilometer per second, and both are same. And if you use the equation of state, it's like US equal to C naught plus S multiplied by UP. So you can see that at higher pressure, let's say 10 gigapascal or 20 gigapascal, let's say at 10 gigapascal, if you should take C naught as the low pressure sonic wave velocity, that means 3.94. C naught is just 3.94 plus if you want to get the value of the parameter S, you can get another table which is or 5.1 in the chapter 5 you can get 5.1 table number, that is page number 133. So there you can get, let's say for copper you can get the S value which is let's say 1.49. So what I am saying is that here you can get C naught as 3.94 kilometer for copper plus S value from that chapter 5 table, and that says that 1.49 multiplied by UP, which is even here, let's say for 10 gigapascal it is written as 0.259 kilometer per second. So if you multiply that and add with C naught, so C naught plus S UP, so that will give you this value, that is 4.425, this other value 4.325. That means when you want to calculate the shock wave velocity at 10 gigapascal, you need to first take C naught, which is the low pressure sonic wave velocity. The value is 3.94 here, plus S is 1.49 from that table 5.1, multiplied by UP, which is in this table itself 4.1, and that is let's say 0.259, and then you will end up with the velocity here which is listed in this table for US shock wave velocity for 10 gigapascal. So I can understand 3-4 doubts where probably it's I could not make you understand well, but hopefully if you check this table and if you go to your doubts again, it will be clear, you will be clear about it. And some of you were asking why we are approximating the shock wave velocity with elastic wave velocity. That's the same reason. Basically that at low pressure we can approximate them as same, and then if it is high pressure, so if you want to calculate US, that is shock wave velocity, so what you need to do is you need to take the C naught, that is the sonic wave velocity at low pressure. In this table it is written as 0 gigapascal, at 0 gigapascal. So yeah, that's what I think I can tell you. And then as I told you about what is that, yeah, as I told you that release wave can be, yes, that can be negative, the pressure can be actually negative, but it is ignored here. And then yeah, I think some of the doubts I will check and then reply you in details. And then you have some doubts regarding I think the pressure and relation with the yield strength, yes, that we need to check, and then I will reply you. One thing that is for sure, that if your impact velocity is low, that will not if it is very low, that will not yield the material. That means plastic deformation will not happen if it is very low velocity, but if it is higher, then the yielding will happen, and then we will see that, but we need to understand that mostly for plastic deformation to happen, especially dislocation movement and mechanical twinning, we need the shear stress, shear component of the stress, not the hydrostatic stress. So that we will discuss later. Mr. Dharmendra, I just want you to write about the assignment for question number 14. So please write it to me in the discussion forum. I got some of your some of you actually already wrote that. I don't know whether you were saying about the same question, and which one? Probably. Okay. So I need to check that. Sorry, I don't have these questions here. I think please write down in the discussion forum, or if you, I think some of you wrote that. I think the question needed to be checked once again, as the values of velocity and pressure does not match for both materials. Only aluminum satisfies one of the answers, but steel does not satisfy anything. So that I need to check. I actually forgot the questions, exact question, and then I'll get back to you soon. I'm not so sure whether the assignment for question number 14 is the same question, but if it is not written in the discussion forum, if you did not send the doubts in the discussion forum, please send it to us and then we will reply. So I thought to to wait for some time and give the replies at a time, and so I will do it soon. And I think if you have any more queries, please you can post it here. So I can see some of you are even joined now. Probably now I can see that 3 watching now. Earlier it was 2. So if you have some queries, please you can post here. Yeah, it looks like not many queries, but I will wait for some time. So if you have something, we can wait and see, and then yeah, about the doubts I will very soon I'll reply in the discussion forum. So I hope that all of you actually arrange at least the Mike Mears book somehow, because I cannot give it to you, and because that book is important. So whatever we are discussing here is from that book, and I accept a little part where I got it from some other books, and I want you to study a little bit of basic fracture mechanics, because we are not going to discuss that while we will discuss on dynamic fracture. So the basic fracture mechanics book, probably you can check Anderson's book, or maybe the other one is Broek, I think David Broek, and then probably even a better book is Professor Prasant Kumar's book. He was a faculty in IIT Kanpur, and his book is quite concise, and maybe some of you already have studied that book. So that is probably a good book for reference if you want to know the basics of fracture mechanics. So because this course we designed it for even for undergraduate students, that's why we can't even go very details of dynamic fracture. Even Mark Mayer's book doesn't have the details, because that is kind of beyond the scope of that book, because the book is mostly focused on the simple mechanics and more materials behavior, materials, even the characterization part that book includes. But for if you want to go for any rigorous dynamic fracture treatment, so you need to study the book by Albie Freund, F-R-E, I think U-N-D. So that I have already listed in the initial lectures as a reference book. But I advise you to first check any basic fracture mechanics book, as I said, like Professor Prasant Kumar's book. Then only you can you should try to go deeper into this dynamic fracture mechanics. Okay, please explain question number 17 of assignment number 1. I don't have the questions with me, unfortunately. So please write it in the discussion forum. I'll discuss that. You are, I think, talking about some elastic wave problem or something like that. So you please write it down. Don't just don't hesitate. Feel free to write all the questions, any doubt or any. There may be some mistakes. Sometimes it may be possible, and from our side. And even if it's not, whatever your doubt is, please be specific so that I can understand easily. So what you can do is you directly write like this, like let's say question number 17, assignment 1, and be specific what is your doubt is, or if you have some I mean, any complaint regarding that problem, so you can please write it in the discussion forum, because that will help others as well, because other participants may also may have some similar doubts, and that will help them, I think. So I can understand you have some issues with assignment 4 question number 14 and assignment 1 question number 17. I think some of these doubts already, especially assignment 1 question number 17, I think I got a query, I don't know from whom, but one of the question I even did not understand, one of the queries what you asked. Kindly be specific again. I mean, I understand that whatever you are asking, I may not understand sometimes, or if I write something you may not understand sometime, that happens. So please, if I am writing that I did not understand that question, please be specific again, and write in a different way, so probably so that I can understand. So I think yeah, I will take care of these questions, but you need to be specific. What is the issue, what is the problem, or why it is not clear, or if you have some complaint against that I made a mistake, so I that should be clear. So I'll take care of that. So I remember probably this, yeah, it may be assignment number 1 question number 17, probably you have asked me something. I mean, some of you, one of the questions I was not sure, I could not get you exactly what was the question. First you write the question number and assignment number, and then write your doubt. I think I got 1 or 2 queries where I did not get the exact number of the question, so that was also that's why I could not answer probably properly. So I think I hope some of you are at least BTech student. I am not so sure about your background. I know some of you are already working, and senior people here, faculty, or maybe working in some company or any I think any industry. So but I am not so sure how many of you are really 4th year student or 3rd year student, undergraduate, or maybe MTech student. So it will be good if you let me know in the discussion forum itself. That will help me. I designed this course for a undergraduate course for 4th year. I mean, that is open to postgraduate or masters or PhD students as well. But I thought that whoever have some background in stress strain and materials behavior, materials basics, so they can understand this course. I admit that I could not probably make you understand all, but I'm sure that some of you who are already experienced in this field and know more about mechanics, and let's say even they have advanced knowledge on materials. I hope that they could understand most part of this course. So, but anyways, we have time till the exam. I think you don't hesitate to post your queries. So I will surely answer these questions very soon, whatever already there, and then other questions I may be out of station for a week or so. We have a mid-sem break here. Then after mid-sem break, I will answer all the queries. So if you do not have any queries, probably we can sign it out, or please let me know if you have some queries. Yeah, do you have any queries, or like I understand that you were waiting for the responses, the already whatever you posted in the discussion forum. So I'll do it very soon. So it seems like yeah, there are no more queries, and already it's I think it's the participants are reducing. I can see only one watching now, so it was earlier maybe 3. So I think probably we can sign it out now, or yeah, or if you want some queries to be answered, so please post it, or otherwise we will sign it out for today. Yeah, I think we can stop now. I think there is no more queries. So we are signing out now, I think, because I got no more queries. So please write all the queries, especially the assignment questions, whatever you have issues in the discussion forum. Please be specific about assignment number and question number, and what is your doubt or complaint number regarding these questions. So I think as there are no more queries I can see, so we are signing out now, and thank you.